Okay, so in this video, we are continuing to learn a few more rules about how to handle limits, and then this section will end with some other information about limits. Now, before we do the next thing, let's just review a little bit of algebra. If I have two binomial expressions like this, remember a binomial is a term for two things added together or two things subtracted. If one of them has addition and the other one has subtraction, but otherwise they're exactly the same, we call those conjugates. So a plus b and a minus b, those are a pair of conjugates. So if I have 3 plus x and 3 minus x, that's a pair of conjugates. If I have the square root of y minus 3 and the square root of y plus 3, that's a pair of conjugates. And something you ought to have at your fingers, maybe this is algebra you've seen before and forgotten, I'm pretty sure you've seen it. If we multiply together a pair of conjugates like this, right, if we FOIL this out, firsts, outers, inners, lasts, what we'll notice is these two middle terms cancel each other out, and what we're left with is the first thing squared minus the second thing squared. This is a pattern you just want to have memorized because it comes up a lot and it's super helpful. If we're multiplying together a conjugate pair, it works out to first thing squared minus second thing squared. And that saves us a lot of time. It's also really helpful if we're doing this with square roots. So let's look at this example. I have the square root of x plus 5 minus 4 and the square root of x plus 5 plus 4. So my a, to use that vocabulary, is square root of x plus 5. Right? It's a little complicated, but it's the same thing in both of them. And then my b is 4. In one version, we're adding them. In one version, we're subtracting them. So the rule here is that it's the first thing squared minus the second thing squared. So if we're squaring a radical like this, that just simplifies everything to x plus 5. And then here we would have minus 16, and that all simplifies to x minus 11. Right, so just file that away. When we multiply together a pair of conjugates, we get a pretty simple answer that would get rid of any radicals because we're squaring stuff. So now we're going to apply that in a technique. If we're doing a limit problem where intuitively plugging in gives us 0 over 0, that's what we keep seeing, right? Oh, I plug in and I have 0 over 0, it's undefined. What do I do? If you notice that there's a radical, here's what you want to look for. You want to find an expression somewhere in your problem that has the following three properties. It has a radical in it has subtraction in it, and if you plug into just that part, you're getting 0. When you see that, what you're going to do is you're going to find the conjugate of that expression, and you will multiply top and bottom by that same thing. All right, a little bit tricky. Let me illustrate this with an example. So here's an example to watch. So I have the limit as x approaches 11 of this whole expression of square root of x plus 5 minus 4 over 3x minus 33. So let's just try plugging in. Always make that your habit. I would have the square root of 11 plus 5 minus 4 over 33 minus 33. So that's the square root of 16 minus 4 over 33 minus 33. And you can check, yeah, it's a 0 over 0 case. And because of the radical, you might not be able to factor this right away, right? You'll notice that the bottom, you can pull out a 3. But we tend not to factor with radicals. That's why we have this trick. But here's what I'm going to notice. I have this radical here. And I notice it's immediately followed by subtraction. So I have an expression here. It has a radical. It has subtraction, this entire expression. And if I plug in 11 just to this part, it gives me 0. So this is the thing I want to notice. And it's of the form something minus something. And so its conjugate would be square root of x plus 5 plus 4. Right? The main plus or minus is here. Don't change this plus 5 into a minus 5. It is this thing, which is a whole thing with a radical, minus this thing. So the conjugate's like that. So here's what we're going to do. Let me just repaste this so it's cleaner. We are going to take this expression, and we identified the conjugate of the important thing. We are going to multiply both top and bottom by that conjugate. And let's just put everything in parentheses now so that we understand how these things work. So here's what's happening. Up top, we have this pattern, a minus b times a plus b. So it's the first thing squared, this is actually the example we saw before, minus the second thing squared. Now in the bottom, we have this whole expression. Don't even think about foiling it out. If you don't think you can do it easily, just leave it. In fact, let's factor this more. So I'm not going to FOIL, but I will notice I know how to factor this as 3 times x minus 11. And then I'm just going to leave it here, not try to multiply it out, that other expression. So let's just make a note here. Don't FOIL. All right, and let's put this back in the main notes. Keep things factored and don't FOIL unless you know it will help. Right. In the numerator, multiplying it together will help because it's a special trick that gets rid of the radicals. In the denominator, if we try to multiply this out, it's a complete mess. So let's just leave it as is and try to factor it even more. So now let's simplify. Our hope is that eventually we can use the old factor and cancel trick. If I simplify the top, I get x minus 11. In the bottom, I get all of this stuff. So after a little bit of work, this thing is complicated, but we notice we have the same factor in top and bottom. You could write this in parentheses so it looks more like a factor. So we can divide it out. We can cancel. Top and bottom both have that factor. We'll divide by it. So this is the same as the limit as x approaches 11 of 1 over 3 times square root of x plus 5 plus 4, all in parentheses like that. Now this looks messy, but let's remember, we had 0 over 0 and we've just canceled it out. So let's give this another look and say, well, can I now use my intuition? Can I just plug in? What if x is equal to 11? So x plus 5 would be 16, so we have the square root of 16 plus 4. Square root of 16 is the number 4. So we have 1 over 3 times 8, which is 1 over 24. Not an easy problem, but you want to get this habit where if you see there's a radical and 0 over 0, you know how to get the ball rolling. You figure out, what should I be paying attention to? What is its conjugate? Multiply top and bottom, and then hopefully the algebra will work out. Right, so with that in mind, try this one. And I promise you it's easier than the example I showed you. All right, so what are you going to do first? You might want to plug in first. You can check that this one is 0 over 0. And we'll notice that here in the top, we have this expression where it has a radical, it has subtraction, and plugging in 9 makes this thing 0. So that's the thing we want to use for figuring out the correct conjugate. Root x plus 3, multiply on top, root x plus 3, multiply on the bottom. So when we do that, and remember, these are all factors, put them in parentheses to be safe. The top, by that trick, is just first thing squared minus second thing squared. The radicals go away. The bottom is quantity x minus 6 times the factor root x plus 3. We notice we have the same factor in top and bottom that can be canceled. So this is the limit as x goes to 9 of 1 over root x plus 3. And now we can do this intuitively by plugging in. This is 1 over the square root of 9 plus 3, which is 1 over 6. This was actually one of the ones from earlier on that maybe you did with a table or a calculator. And from the table or calculator, you may have gotten that as a decimal, the answer is something like 1.66. But it may not have been obvious what's special about that number. Right? There are a lot of fractions and things with radicals and pies, where when we write it as a decimal, we just don't recognize that that's an interesting number. Here, when we do it analytically, we can see, oh, the answer is just this simple fraction, 1/6. This actually feels easier in fraction form than in decimal form. Okay, we will pause again just to keep each individual video short.